Welcome to my channel. I'm Zhang Xu. Let's look at the problem 13 in chapter 29. Chapter 29 is about electromagnetic induction and Faraday's law. So in this system, we have a gold ring, right? It's a loop. And then for this loop, we know its magnetic field changes from 0.8 t to 0. So we can write it there. This is a change of magnetic field. So final is 0. And initial is 0.8, we get answer there. And the time taking tell you 45 second, right? So you can write it there and convert the unit millisecond to second. Next one tell you diameter in centimeter, so write it there. And the resistance is given, write it there. Mass is given there. Next one. First one, we need to find the thermal energy produced in the ring due to the flow of induced current. So now we need to find the induced energy. That is easy, right? So induced energy, as we talk about, should be the power times time taking. Agree? Yes. And then, so we can see, so the power times delta T. This is the total energy. The magnetic field just give the ring, right, the loop. So next one, delta T is given. We need to look at the P, power. As we talk about, the power can write as the induced EMF squared divided by R, right? This is in our Ohm's law chapter. You can check it if you don't understand, right? So R is given. Look like we need to find epsilon, induced EMF. So now induced EMF, as we talk in this chapter, this is the change of magnetic influence divided by time taking is the EMF, right? So now we can write it there. Now the magnetic influence is B times A, right? So there, the change of magnetic influence is the change of the B times A. Agree? A is cross-sectional areas pi r squared, right? So diameter divided by 2 as the radius. Now you can see we can work there. So we write down Q at there and P we replace it there, right? Replace the P as epsilon squared divided by R and then replace epsilon in this equation, right? And then input is A in this equation. So now you can see you get it look like this equation, right? And reorganize it, you get it there and input all the given quantities, get answer there. The next one, find the temperature rise of the ring. So that means we need to find how the temperature changes. And the quantity given is the specific heat of gold, right? So that is easy. As we talk about the energy, right, of the thermal energy is Q equal to Cm delta T. So Cm delta T, you can see C is given, mass is given at there. So very easily you can write down the function for delta T. This is the temperature change. Input all the given quantities, get answer there. Thank you.